Hi, my name is Jimmy Bailey, and I'll be speaking briefly on the topic of continuity. Oh, and by the way, I'm attending Challenge 2009. Anyways, the basic description of continuity is being able to draw a function on a set domain without having breaks or having to lift your drawing instrument on a function. Now, the mathematical description for continuity is having the limit of said function f of x as x approaches a. We put here a right here. It will equal f of a, which would be y. So the limit of this function as x approaches a would equal y. And that basically is continuity. Now let's look at discontinuity. Discontinuity is when you have a break in that function. Now, the limit is still going to equal y. But let's suppose we have another point here where the function will be defined at b. Sorry, let's change y to c, as it would be confusing, and I don't want you to confuse it with the y-axis. Okay, so instead of f of a equaling y, it will now equal b. So the limit of f of x as it approaches a is not equal to f of a, and that will be discontinuous. But if we found a way to get this point here and somehow fill it and meet the requirement that we said before for the limit to equal where that function is defined, it will be then again continuous. Now there's different types of discontinuities. This one is called a removable discontinuity, and a sample equation for a removable discontinuity would be, let's say, f(x) equals x squared minus 4 over x minus 2. In that, when you plug in 2 for this equation, the answer would come out to be 0 over 0, undefined. So f of x, meaning f of 2, the function at 2, would equal 0 over 0. Thus we would have a break in that function. Now, to get a point in that function, we can simplify this equation so that we have, let's break up that and have x plus 2 times x minus 2 over x minus 2. And by dividing, we have left over x plus 2 over 1. Now, the simplified version, plug in 2, will have 4 as the answer. So, let's say this is a different function now, g of 2 would equal 4. That way, we'll meet the requirement again, and this function would be continuous. Now let's look at a different type of discontinuity other than the removable discontinuity, which would be, different types of discontinuities are, first, the removable, where the limit of the function as it approaches a would be b, while the function is actually defined at c. And if the function is rational, which this would work for all rational functions, by simplifying that function, you'd be able to move this point back into here, basically, to make the function continuous. Now, the other type of discontinuity would be jump discontinuity, which, well, basically defines it real well as it comes at a point, then jumps to that other part of the function, and then continues. Now, on this example, on the left side of this function, it is discontinuous as it approaches 0, and on the right side, the function is defined at 0. Now, the next example of discontinuity is infinite discontinuity, where either both sides are going up towards infinity, or one side is going downwards to negative infinity, where there would be no limit. And basically, that's continuity in a nutshell.